So looking at the next one, we have another situation. It says the following two-way table displays partial results when 100, so we can put that as a total, 100 Saugerty students were asked, are you in junior high, do you snowboard? And they're definitely ready at this point to try this, if you would like. The JVD event, the students in junior high, and the SVD event, the students snowboards. So we're going to fill in the rest of the table. So this is going to have to add up to 100, so that's 60, 30, a 58, subtracting backwards, I get a 32, and over this way, I get a 42, and just a quick check on the two that I didn't compare, those two do add up to 100. So now we're going to find how many students are in certain groups or sets. So how many students are in the intersection of snowboards and a student is in junior high? So I wrote some notation for it. So looking at where S and J intersect, I get 10. In the complement of the event, a student is in junior high. So this is not in junior high. So the total not in junior high is 60. How many students are in the union of the events? A student snowboards and a student is not in junior high. So this is our little bit trickier one. So I need all the snowboarders, all the not junior highs, and subtract out their intersection. And when I take that in, or just calculate that, I might calculate something down. All the snowboarders. So all the snowboarders is 42, plus 60 minus 32 is going to be 7. Now we're going to see probabilities can also be calculated from two-way tables. So as in the first lesson, for basic probabilities, you're going to divide the number of elements in the desired subset by the total number of elements in the set of possibilities. Now, this is another way these tables can show up. So sometimes they'll give you all the inside information and you have to find the totals. So this takes, bigger numbers, probably need a calculator. So this is just totals. So I'm going to add these two up and see what I get. So looking at this, I have the 113 plus 282, and that adds up to 395. This one adds up to 543. 938 as my two totals add up. 185 and 753 as I add across, and that does also add up to 938. So it says, what is the probability that a randomly selected student has at least one household member that smokes? And I probably should back up. The information in this table says, do you have at least one household member that smokes, yes or no? And do you have asthma? So we're going to give these letters so we can write it. So maybe I use an S for the smoking and an A for the asthma. So they want the probability that if we randomly selected one of the 938 students, they have at least one household member that smokes. So we want the probability of S. So when we do probability, first off, the number of elements in S is 395. Out of the total number of elements in the whole set, which is 938. So we just write those two down. It doesn't ask me to round anything, so I'm just going to leave it as a fraction. I'm not really going to write out something. The next one, the probability that a student does not have asthma. So that's probability of not asthma. So there's 753 students that don't have asthma out of 938. So this table I just copied from the last page and basically have all the totals ready to go. So we're going to continue answering these questions. As I said, try them on your own. Suggestion. What is the probability that a randomly selected student has a household member that smokes and has asthma? So we want my letters on here. Household member that smokes, and so that's an intersection with asthma. So if I look at that intersection that's right here, so 113 out of the 938 students fit that criteria. What is the probability that a randomly selected household student has a household member that smokes and does not have asthma? So that is going to be smokes and does not have asthma, or someone smokes and there is no asthma, is 282 out of 938. What is the probability that a randomly selected student has a household member that smokes or has asthma? So now we have one of those ors. Now the or, we know we add up all of the people that have a household member that smokes, all of the people that said they have asthma, and we subtract out, right, we ended up counting the 113 twice, so we subtract out the 113 out of 938. So I'm just going to take on that numerator, and it does come out to 377 out of 938. What is the probability that a randomly selected student does not have a household member that smokes or does not have asthma? So no household member smokes, 543. No asthma, 753. Intersection, 741 out of 938. And typing in that numerator, I get 825 out of 938.